So good afternoon, everyone. It's Mrs. Spencer, and I'm here to talk to you about Chernobyl's legacy. There's an anticipation guide in front of you, which is what you'll complete in class and turn in. And prior to reading, you should do the first column that you see on this table, where you decide whether you agree and put an A in the column or a D if you disagree with the statement. Okay? I'm going to go ahead and read this because I do have sight-impaired student, and I hope that you enjoy this activity. So please think about the following questions as you listen to the article. The first statement that you should decide whether you agree or disagree with is, number one, most of the people who left Chernobyl after the nuclear plant explosion have returned. So decide whether you agree or disagree. Number two, the accident at Chernobyl occurred during a safety test. Agree or disagree? Number three, temperature inside the reactor during the explosion were as hot as parts of the sun's atmosphere. Agree or disagree? Number four, the fuel in the reactor included uranium-238 from enriched uranium dioxide. Agree or disagree? Number five, a radioactive cloud blew across northern Europe after the explosion. Agree or disagree? Number six, isotopes of the same element have the same number of neutrons. Agree or disagree? Number seven, when 1 mole of uranium-235 undergoes fission, the energy released can power about 400 average U.S. homes for a year. Number eight, nuclear reactors must have control rods to keep a chain reaction from occurring. Agree or disagree? Number nine, radioactive strontium can lead to bone cancer. Agree or disagree? And number 10, the radioactive iodine released during the explosion still poses a health threat to people in northern Europe. Okay? So hopefully you decided whether that sounded like something you would agree or disagree with. And now I'm going to read the article so that you can try to answer those questions. Folks from class, you should also answer the rest of the worksheet, which is a couple more pages. But for my sight-impaired students, those are the questions that you should complete together. Okay? So nothing more on the screen that you will need to see, but I will continue by reading the article now. Chernobyl's Legacy by Adrian Dingle. Chernobyl. The name refers to both a town and a nearby defunct nuclear power plant in what's now Ukraine. But to many people, the name has become synonymous with nuclear disaster and what can go horribly wrong in the world's quest to electrify cities with nuclear power. The explosion of one of the plant's reactors exposed hundreds of thousands of people to radiation. It forced some 350,000 people in the surrounding areas to leave their homes, according to the International Atomic Energy Agency. Access is still restricted to what's known as the exclusion zone, which encompasses the land within 30 kilometers, about 18.6 miles, of the plant. But more than 100 people now live in or on the edge of the zone. Much of the soil remains contaminated with radioactive materials, but scientists monitoring the zone say that breathing the air is safe. Details about the causes of the explosion have been well reported, but the world is still contending with its lingering effects and fears of another Chernobyl-like event. More than 30 years later, are the concerns still warranted? Page 2. What caused the explosion? In the spring of 1986, operators at the Chernobyl power plant set out to conduct a safety check to see if the plant could work safely if the main power source were interrupted. As part of the safety test, one of the 4 reactors was reduced to a low power state. A series of operator errors coupled with the reactor's poor design led to a power surge at 1:24 a.m. on April 26th. The rush of energy was enormous. It caused thermal power to reach a level of 12 billion watts. The pressure inside the reactor shot up and the temperature reached a staggering 4,650 degrees Celsius, about the same temperature as parts of the sun's atmosphere. These conditions inevitably caused the reactor to melt down, and an explosion blew the steel and concrete structure to bits. Metal, graphite, and lethal radiation was blown sky high. Winds blew the radioactive cloud across northern Europe. How did the reactor work? The reactor was a Soviet-produced RBMK reactor Bolshoi Mashino Nazi Kalani, which translated from Russian means high-power channel type reactor. In the core of the reactor was the fuel, 190 tons of enriched uranium dioxide. The uranium is said to be enriched because it contains a higher percentage of the isotope uranium-235, the isotope used for nuclear power, than is found in naturally occurring uranium. Naturally occurring uranium has approximately 0.7 of uranium-235. Enriched uranium is 3% to 5% uranium-235. When the nucleus of the uranium-235 atom is bombarded by a neutron, a nuclear reaction takes place. The neutron splits open the nucleus, a process known as fission, and releases new daughter nuclei, more neutrons, and energy. The reaction can play out in many ways, generating different products depending on the conditions. The following reaction is one example of what can happen in uranium-235. Uranium-235 combines with a neutron, producing krypton-92, barium-141, and 3 neutrons and a whole lot of energy. The reaction of a single atom of uranium does not release very much energy. The reaction above typically produces about 2.7 times 10 to the negative 11 joules, but repeated on a scale of a mole, that is 6.02 times 10 to the 23rd times, the energy release becomes significant, enough to power 400 average U.S. homes for an entire year, all from the reaction of about half a pound of uranium-235. Controlling the reaction. Nuclear power is based on 2 properties of nuclear fission. Number 1, it produces a large amount of energy when scaled up, and 2, the neutrons that are produced can react with more uranium-235 nuclei, breaking them apart and producing more neutrons. The result is a self-sustaining chain reaction. The chain reaction produces a lot of energy very quickly. Without moderation, the process becomes dangerous. Careful monitoring and management are required. One way to control the reaction is to lower control rods into the reactor's core. Control rods slow down nuclear reactions by absorbing neutrons, which keeps them from reacting with the uranium and generating more energy. Basically, it stops the chain reaction. Chernobyl's RBMK reactor had 211 control rods. The accident investigation showed that at the time of the explosion, only 8 control rods had been in the 7-meter-tall core, when at least 15 should have been in place. This critical error, along with subsequent missteps, ultimately led to the explosion. What is the human toll? As a result of the initial explosion, 2 people were immediately killed. In the following 2 weeks, more than 24 people died from acute radiation sickness, which occurs when exposure to radiation goes well beyond background levels. The ionizing radiation produced in nuclear reactions damages human cells. This leads to a host of symptoms, including vomiting, diarrhea, headaches, and fever. Over time, cancers such as leukemia can also result. Long-term health effects can also result from the radioisotopes that the explosion spewed into the atmosphere and settled into the soil and water. As mentioned earlier, the nuclear fusion of uranium-235 can yield many different lighter products which can undergo radioactive decay to create a mixture of radioisotopes, such as iodine-131, cesium-137, and strontium-90. These radioisotopes can cause a variety of health issues. For example, iodine-131 tends to concentrate in the thyroid gland and can cause cancer. Strontium-90 can mimic fellow group 2 member calcium and accumulate into the bones and lead to bone cancer. Iodine-131's effect is relatively short-lived, with a half-life of only 8 days. In contrast, cesium-137 with a half-life of 30 years and strontium with a half-life of 29 years remain threats for a much longer period of time. Last page. The number of premature deaths that have resulted from Chernobyl, however, is difficult to determine. An estimated 600,000 liquidators were brought in to clean up the mess that resulted from the accident. These were people. Some of them died of cancer or became terminally ill. In addition, an increase in thyroid cancer rates in the region has been reported. Nuclear power today. After the Chernobyl disaster, RBMKs were redesigned, and no major incidents involving this type of reactor have been reported for 2 decades. The most recent nuclear meltdown occurred in 2011 in Japan, when a tsunami flooded the Fukushima power plant. No deaths or cases of ARS were reported. Nuclear power continues to be an important contributor to low-carbon energy, although concerns about safety, long-term waste disposal, and high building costs have dampened the industry's growth. Moving forward, the world could become less reliant on it as renewable energy such as solar and wind continue to ramp up. Even then, the legacy of Chernobyl will endure. All right, guys. Well, I hope that that information is helpful to you and that you enjoyed it and learned something cool. Please try to remember some of the questions originally asked. Actually, let me go through them again because we have time. So the questions you're answering are, did most of the people, number 1, who left Chernobyl after the nuclear power plant return? Number 2, did the accident at Chernobyl occur during a safety test? Number 3, did temperatures inside the reactor during the explosion reach as hot as parts of the sun's atmosphere? Number 4, did the fuel in the reactor include uranium-238 from enriched uranium dioxide? Number 5, did a radioactive cloud blow across northern Europe after the explosion? Number 6, did isotopes of the same element have the same number of neutrons? Number 7, when 1 mole of uranium-235 undergoes fission, does the energy release have enough to power about 400 U.S. homes for a year? Number 8, do nuclear reactors have control rods to keep a chain reaction from occurring? Number 9, can radioactive strontium lead to bone cancer? And number 10, does the radioactive iodine released during the explosion still pose a health threat to people in northern Europe? Thank you so much, guys, and have a wonderful day.